Good morning and welcome. My name is Brian Wilson. I'm with TriStar. TriStar is PTC's largest North American partner. And I'd like to welcome everyone out to our Resolve Failure webinar today. We're going to be talking about resolve mode, what happens when a file is in resolve, what are the things we can do, and sort of, what causes them, what options do we have. So before we can get started, I'd like to remind everyone of our time-limited offers from TriStar that are actually expired today. First is a 35% off on simulation and analysis solution tools, which is a pretty good deal for FEA and those type of simulation analysis, as well as certified virtual training, 18 to 60% off any scheduled virtual training, which is done via the web. Next is the MathCAD product, which enables you to do engineering calculations, integrate directly into Creo. And last but not least, ANSYS simulation for full-scale FEM analysis and simulation, complete with a 21-day free trial license with support. And all of these things are available. Remember, the time-limited offer is actually in today. So if you have any questions or would like to get more information, reach out to your sales rep and they'll be glad to help you with that. So once again, let's get started. I'm Brian Wilson, and today we're going to talk about resolve. Okay. So the first thing to know is what causes resolve. We're going to do a few slides. I'm going to talk about part level failure. I'm talking about assembly level failure, investigation of failure, and what we can do to get more information. Okay, and what kind of tools we have to fix the problems. Okay, so you have to understand that when a model regenerates, it regenerates from the top down, in the order in which it is in the model tree. So if it's a part, it regenerates the features in the order in which it was created, or the order it's listed in the model tree. And the same with an assembly. The assembly regenerates from the top up, regenerating each component and its placement. Once again, in the order it is in the model tree. Okay, so when it gets to something it can't regenerate, that feature or component fails. It fails to regenerate, and that's where we have a resolve issue. Okay, so at that point, things are going to happen to us. The first thing we're going to notice is in our taskbar down at the bottom, we're going to get the regeneration manager. We're going to get the red light here. Red means that there's at least one feature or component in failure. If it was green, that means everything is up to date and regenerated, and yellow tells us that it needs to be regenerated. Other things you may notice, in the model tree, the failed feature or component is going to show up in a bold red here, with the child or children in red but not bold. On the screen, if possible, it will show the failed feature in red and the children in blue, so you can differentiate between the parent and the children. Not always does it show this on the model, but in a lot of cases it does. So you're going to have that visual information as soon as it happens. If you were to click on the regeneration manager icon, you would actually pull up the regeneration box, which gives us more information or can allow us to investigate a little more about the failed feature and its children. Another important piece that you will notice is the regeneration caption. Some features fail to regenerate, or some components fail to regenerate. Choose OK to accept results, or Cancel to undo the changes. So in some cases, Cancel will undo whatever you did that caused the problem. If you click OK, basically you're saying to leave it in resolve so that you can then fix the issue, resolve the problem. Okay. As an overall arc, features, components, they fail for a few basic reasons. Invalid or impossible geometry, missing or models or references. Those are the kind of things that cause failure. And we're going to talk about each of those, some of those options, I guess, individually as we go along. Okay. So the first is geometry failures. Geometry failure is caused when geometry has been changed, so it's been made invalid, where the geometry can't be created. It's impossible to create. In figure 1 there, for example, you see the round on the edge of that cylinder. If the round gets too big, where that it's too big to fit, it overlaps itself, and then we're going to have a failure. In figure 2, for example, if the radius in our sweep trajectory is small, so that when our section tries to sweep around the corner, it overlaps, it may fail or take you into resolve. A blend with the start points aren't aligned properly. If the twist is too much, then it will overlap, and it's liable to cause failure. Okay? Extrude through until, if you extrude it up to some surface and something happened to that surface that became invalid or missing, then those are the kind of things that could cause a failure. Okay? In this case, it's about the geometry. If you change something in the sketch, for example, that caused the sketch to overlap, these would be things that would cause failure. Okay? So things to think about. Analyzing geometry failures. Geometry failures are one cause that a part may fail. A second cause is open section failures. Okay? Open sections are sketcher sections which don't form a closed boundary. Normally, open sections are bounded by other solids. In order to create, in this example specifically, this feature here, this tooth, it's bounded by this surface. The problem is, if the tooth becomes taller than this surface, there's no boundary at the top. Okay, so it would be important for us then to fix the problem. That's going to cause us to go into resolve. So in this case, it's pretty simple. We close this and make it a closed section, and that fixes our problem. As a general rule, closed sections are the most robust. However, there are some applications and techniques which require the use of an open section. The behavior of the model is different. So it's all about whatever allows you to have your design intent. But as a general rule, if you're not sure, close the section. Okay, so open section failures. Missing part references. This is probably, in my mind, probably the biggest one that you'll find. These occur when a parent feature is changed, and the child then can no longer reference the parent. For example, in figure 1, this slot is referenced to this axis in the center of this hole. If something happens to this hole or this axis is removed, then this slot's going to be missing a parent, thereby it's going to fail. If, in this example, this round is on the edge of this ear, if something happens to that ear and it's no longer there, the round's going to be missing a reference. It's going to fail. Even in Sketcher, if we change Sketcher entities, if I come in here and change this arc, change this line rather, to some other shape by sketching another entity, there's a good chance that they're going to cause a failure, because there's a good chance that that has children. If you ever get this message, this entity is referenced by others, continue, and you say yes, that means there are children, there's a pretty good chance that you're going to have a failure, which then you're going to have to resolve. Okay, so just to recap, parts for a basically have 3 reasons: geometry that can't be created, open section failures, and missing part references. These are a couple of things, or the few things mainly cause problems in parts. In Creo 3, one of the new tools which really make it easier when you have missing references is the displaying of missing references. So if your model is regenerating in Creo 3, once it's been regenerated the first time successfully, I guess, it will then, when you have a failure, to show you the reference highlighted here as to what it was referencing, even though that doesn't exist. Okay, so for example, this is telling me that this round that's in failure is referencing that edge. So it enables me to have a better understanding, more easily choose the correct edge. Okay, for example, this surface has a reference, or this sketch that has a reference to this cylindrical surface which no longer exists. I can use the replace in the sketcher references to choose a new reference. This display missing references is available in Creo 3. Okay. So as far as assemblies go, okay, assemblies have a few reasons why an assembly might fail. The first being missing components. In order for your assembly to regenerate successfully, it has to be able to go out, find, and regenerate each component in that assembly. If for some reason or other it can't find one, then that component is going to enter into resolve. There's a few reasons why this happens. First, the renaming of the component in the operating system. So if I went to Windows Explorer and renamed a file, the assembly that references it wouldn't know. Okay. If the component was located in a different folder than the assembly, by default, the assembly is going to look in its working directory for its components. If one of the components is in a different directory, then it can't find it. It's going to be missing. Okay. Another pretty common, goes back to the rename, is if I open up a component in Creo and rename it in Creo without the assembly open, then the assembly is not going to know that that rename took place, so that the assembly would fail the next time. So just a couple of tips here. One, never rename components in the operating system in Windows Explorer, for example. You're just asking for trouble there. Second, it's very important when we rename in Creo, in the Creo tool, rename a part, for example, that we have all of its dependents open. Okay, for example, all of its assemblies and drawings that reference it open, so that they know that the change has taken place. Now, if you're using a data management system like Windchill, for example, this is not as big an issue because, first of all, Windchill handles the rename without a problem. It also knows where to look for the components. So missing components failures are not very common when dealing with a data management solution like Windchill. Now, they still can occur, but they're just not very common. So missing component failures, not being able to find the components themselves. Okay. Second, missing component reference. Okay. So this usually happens when a component has been modified that breaks a reference that's used in the assembly placement. For example, if I put this rod coincident here to the hole in this block, then I open up this block and I remove that hole, that rod's going to fail because it's not going to have its placement reference. So placement references are missing. Okay, so the thing it was assembled to is no longer there. If I assembled a bolt into a hole and then I open up the component with the hole and I remove the hole, the next time in the assembly the bolt would fail its placement because its feature reference or component reference is missing. Okay. So missing component reference failures. That's sort of the second reason why an assembly would fail. Third, invalid assembly constraints. Okay, and this occurs when components are being changed so the constraint sets become invalid or conflict with one another. Okay. So for example, in figure 1, if I have a coincident between this rod and the hole in the back plate and this rod and a hole in the front plate, that's fine. But if I change the holes in the front plate so that they don't line up, the placement constraints now are invalid. Okay. They're conflicting one with another. Okay. So we have to do something to resolve them, either constrain the component differently or modify the components so that the constraints are valid again, or maybe even suppress or suspend the component, maybe even freeze the component. These are some of the options we have. Okay. So for parts, it's invalid geometry, or geometry that can't be created, open sections, and missing references. For assemblies, it's missing components, missing references, and invalid assembly constraints. Those are the most common of the types of resolve issues you will run into in Creo today. Okay, so what I'd like to do is just go right over into Creo now, and we'll pull up a few models and we'll make some changes. We'll cause some failure, and we'll look at the options and we'll resolve them. So the first one we're going to look at is part invalid geometry. So in this example here, okay, I can edit a feature. For example, if I edit this chamfer, the first thing I want you to see is with the new dynamic edit tools, if I drag this to a place it can't be regenerated, you'll see it turns red immediately. Okay, and that tells me that that's going to fail. Now, I haven't closed it completely yet, so I can actually put it back. As long as it's not red, okay, I'm okay. I also can cause failure, of course, by changing a value to something which is impossible to create. Notice when I do that, it immediately fails. Okay, it shows me here on the screen the chamfer is in failure. Okay, the round here is a child. Also, those are denoted in the model tree. Notice the chamfer is bold here with the little symbol, warning symbol, and the round being red, being a child of it. Also notice the some features fail to regenerate box. If I click cancel, that's going to put it back to the size it was. If I choose OK, that's going to go ahead and leave it in failure. So now it is officially in failure, if you will. If we look, we have a regeneration manager, which shows us a little more information about the feature that failed and its children or child. In this case, another one that I like to use is feature info, which gives me some information. The chamfer failed regeneration, it is not up to date, which isn't that helpful in this case. Some of them are more helpful than others. So, in this case, the only really thing we can do is to change the chamfer back to a more reasonable size. Okay, so I'm just basically going to put it back, and notice once I do that, the failure is resolved. Immediately the red goes away, the regeneration manager turns back to green. Okay, so the geometry now can be constructed. Another example here is if I change the radius on this trajectory here, we're going to go from 2 to 1. Notice immediately that fails. Okay, I got my failure list here. I'm going to go ahead and leave it in failure. I've got my regeneration manager telling me that the sweep failed. And if I look at it, it tells me could not construct, okay, which means overlapping geometry or something impossible to create. So in this case, what I'm going to do is change the actual cross section to make it small enough so that it can regenerate. And when I do that, you'll notice it should look better, and now everything should be up to date. Okay, so can't create the geometry or impossible geometry. That's sort of the first reason that a part may fail. Okay, so let's look at the second one. The second one is the open section. The open section is going to occur when an open section doesn't have a boundary. If we look at the left tooth, if we go to its information, feature information, we can see here that it is an open section. Okay, and it is bounded by this surface here. Okay, so as long as it can create that boundary, it's fine. But if I edit that and I make this taller than the boundary, notice immediately I have a problem. Okay, so I can say OK, and then let's look at our regeneration manager again. The left tooth, okay, could not intersect part with feature. This is usually your open section failure. Okay, so we have to do something. In this case, it's as simple as changing that section to close it. I'm going to use my center and ends arc here. Notice it's now shaded, which tells me it's closed. And once I do that, then I will have resolved the issue. I will notice that the right ear was already, a right tooth rather, was already a closed section. And it's actually referencing its height off of the left tooth. Okay, so there's no problem there. Okay, so open sections, something to be careful with. Remember, as a general rule, if you're not sure, close the section. But there are cases where open sections allow us to create some geometry and have some design intent that otherwise couldn't be created. Okay. All right, next is missing references. I'm going to show you a couple on this one here. First of all, I've been tasked with changing this geometry from a straight here to a slight arc in the connecting rod. So I'm going to go back to the base protrusion, edit its definition. Now I'm in Sketcher. I'm going to delete the straight line. And notice when I do this warning. This entity is referenced by others. Continue. And if I click yes, then I'm pretty well assured that I'm going to have a failure, because this tells me that there are at least some children to this entity. I'm going to put a really slight arc in there. And notice the side round failed, the top round, the bottom round are children of it. Okay. If we look at the side round, okay, feature references are missing. Okay, once again, so there's a reference missing, so we have to fix it. Anytime there's a reference missing, I like to start with edit definition. Okay, by editing the definition of the failed feature, I'm looking for red. In the Sets tab is red, and in Set 1 there is a missing reference. And if I choose here, notice in Creo 3 it displays the missing reference. And highlighted in this red is the surface. So in this case, all I have to do is replace that with a new surface, and I have fixed the problem. Okay, thereby resolving it. Okay, now I've got to do the same on the other side. I'm going to do it a little different to show you another technique that you may or may not be aware of, which has been around for some time. I'm going to put a center line in here. I've got my arc on the other side, and this time we're going to use a function in Sketcher called replace. And the way it works is if you sketch the new entity, you can select the old entity, right-click and use replace, and then you pick the new entity to replace it with. And it'll give you this about not being able to regenerate the dimensions, and we're going to say OK. All right, so now any references that were to that straight line are now automatically mapped to this arc. Okay, thereby it's going to automatically regenerate successfully. So replace in Sketcher is a very powerful tool that can be used. So when you're in Sketcher, if you're going to be deleting geometry and replacing it with another piece of geometry, use the replace tool. That way you'll map your children appropriately. Okay. The next one I want to go through is this idea of missing references. And I showed you briefly in the previous exercise. But here is a plate, it's got a boss and some profile ribs here. I actually have been told I have to change the shape of this from a circle to an octagon. So I'm going to go back into the sketch. I'm going to delete the circle. And there's the message about the children. And we're going to say OK. I'm going to use my palette and pull my octagon out here. I'm going to scale it. I'm done scaling and rotating the octagon. And I'm done with my sketch. And immediately I enter into a failure. All these things are failed or children of failures. Okay. So I'm going to go ahead and just say OK. Okay. So I'm just going to start with the hole and look at it. If you look at the placement, okay, axis is missing. Notice how it's highlighting the existing hole axis. The existing axis that was in the original boss, even though it's no longer there. So in this case, I need to replace it with another axis. Okay. So in this case, I want to choose that axis as to replace it, and that's the axis actually in the base circular extrude. Okay. So we have fixed that one. Now we'll do the same thing with the round. If you look at the round, it tells me that it is rounded on that edge, which no longer is there. So I'm going to replace it, and I'm going to select the intent surface top edge, okay, to round as well. And once again, it's updated. And let's go on down. Now our profile rib is failing. I'm going to go into Sketcher. I'm going to notice that there is a surface which is missing, which was a Sketcher reference. So in the Sketcher reference box, you have replace, which is another place you can replace. So I'm going to replace that silhouette surface with this surface here. And I'm going to close that. I'm going to go ahead now and look at that. Looks good. Okay, it looks good. One of them now, but now it's the pattern that's failing. So we're going to go back to it, and it's referencing the axis once again, which was in the original boss there. We're going to choose our base axis to replace it with, and now we have resolved the problem. Okay, by using those display of missing references, it makes it much easier for us to follow what's happened. Okay, so just a couple of things there to think about. So remember, at the part level, invalid geometry, open sections, and missing references. So let's look at a couple of assemblies now. Okay, first we're going to start with the missing component. Okay, I'm going to open the missing component fail assembly. Okay, and the first thing I notice is jaw slide is missing. Okay, so one of the options I have is in the right click is to retrieve missing component. So I'm going to go over here and I'm going to look in my folder, and jaw slide is not there. Here's one jaw slide. Here's the problem. Okay, the problem is this was renamed either without the assembly open in session or using the Windows Explorer. So I'm going to go right here and I'm going to rename my jaw slide back to the original name. Okay, and now I'm going to try that retrieve again, and now I can retrieve it. Okay. Now we still have another failure. Okay, the handle part is missing. So let's retrieve. Okay. Now we could retrieve. We also could go out and open that file into session. A couple of different techniques here. In this case, it's not in my directory. It's in this handle folder directory. Okay, so I'm going to open it, and that's going to fix the problem. However, the next time I open that assembly, it will still fail because that component is not in the proper working directory. So in this case, I'm going to go here and I'm going to take my handle part and I'm going to copy it into the correct folder where my assembly resides. That way, it won't have any trouble the next time we try to open that assembly. Okay, so these are the things to think about. Okay, either components that have been renamed, we may have to rename them, or we may have to go out and find a missing component and make sure it's in the proper location. Remember, with data management, this is not as big an issue because Windchill and other data management tools handle the component renaming as well as the finding and retrieving of all appropriate components. Okay. Next one we're going to do is missing references. I'm going to open up this jaw slide. I've been told to change this from a flat bottom hole to a drill point. So we're going to change the way it's machined. So we're going to put the drill point angle in there. Okay. Then I'm going to say OK. Looks good. Now I'm going to open up that assembly. And immediately I notice red here. If I expand that, the lead screw has failed. The handle is a child of it. If we look here in our regeneration manager, it tells us feature references are missing. So that means in the assembly there's a constraint that's missing a reference. Okay. So I'm just going to start by looking at the lead screw. Okay. And what I can see here is that the coincident that this is referencing, which is to the back of this, to what was the bottom of the flat hole in the hole, the bottom flat surface, is no longer there because now it has a drill point. Okay, so we have to do something, reference it differently, or change the component so that we can, those references still exist. Okay, so in this case, maybe we need to change that back to a flat bottom hole here, or maybe we need to assemble it and reference it off the back of the plate with some kind of offset, or use some other assembly technique. Okay. In this case, I'm going to go back to the jaw slide, change the hole back to a flat bottom, and then if I go back to my assembly, I should be able to regenerate it, and everything should now update, because now the placement constraints are found, and it has no problem with that. So missing component references. That's the second sort of reason why assemblies fail. And the third is invalid constraints. I'm going to open up the the invalid constraint subassembly here. And I've been tasked with moving these holes out to make the spacing differently. So I'm actually going to open that component, which is the fixed jaw, and I'm going to change the location of this hole. And move it out a little bit. And then I'm going to go back to my assembly and regenerate it. Notice now I'm in failure. The rods are failing, something in the jaw subassembly is failing. Okay, we don't really know yet. If we look at our regeneration manager, failed to regenerate component placement. Okay, this means that the placement constraints are invalid. So what we're going to look at is the rod and see how it's constrained. I'm going to edit its definition. It's coincident to the hole down here. It's coincident at the end of the rod to the back, and it's coincident to the hole up here on this end as well. Well, that's a problem because the holes don't line up anymore, so that's causing our constraints to be invalid. Notice the red here in the dashboard. So temporarily, I'm going to disable this constraint here, and notice it's still fully constrained even without it. Okay. Now that one is no longer in failure. I'm going to do the same with the other rod. Okay, now the jaw subassembly. Okay, it's aligning to that as well. Okay, so we have to fix it as well. So let's do a couple of things. Okay. First of all, in order to fix this, I need to modify this component. So I'm going to select it, and I'm going to activate it and actually work right here in the assembly for a minute and move its holes so that they now line up. Okay. That looks all fine and dandy. Now the jaw slide has the same problem, like this one. So I'm going to activate it, and I'm going to change its holes and move them out so they line up as well. Now everything looks good here. Just to make sure, I'm going to go back to my rods, and I'm going to re-enable those two that constraint. Okay, it's re-enabled. Everything is still fully constrained. I'll do the same with the other rod just to make sure that everything looks fine, and it does. Okay, so in this example, our goal is to keep these holes always in line. That's the reason we constrained it this way. So if for some reason one of these components changed and the rod is no longer in line, it will throw a failure in the assembly. That was our design intent. Okay, now I didn't have to assemble it that way, but that was the technique I used to maintain that those holes stayed in line. Okay, so as you can see, invalid constraints are a very common type of issue when it comes to assembly failures. That and missing references are probably the two big ones. Okay, and that's all I have for today. I have a couple of questions in the queue I'd like to answer. The first one is about the replace and sketcher. Wants to know if that replace and sketcher is new to Creo 3. And it is not. Actually, it's been in Creo since back in Wildfire at some point in the early builds of Wildfire, so it's not a new function. The displaying of the missing references, where when we did the one with the ribs that we saw the references highlighted for the missing references, that is new to Creo 3. And remember, that only works if the model has been regenerated in Creo 3 successfully at least once. The second question we have is about the config option to allow the save of failed models. Do I think that that's a good idea? Personally, I do think that you should be able to save your failed models, because I want to be able to maybe save it at the end of the day and be able to come back and pick it up and work on it tomorrow. So, I think I should be able to. Now, there are obviously some downsides to that. You don't want to leave a model. You don't want to put it back in its, final position, whether that's in a shared directory or especially if that was like checked into a data management system like Windchill. You would never want to check in or put back in its final position a model that had failure in it. So you need to do something to correct the issue. Okay. So those are a couple of things to think about. If we don't have any other questions, I appreciate your time today, and we look forward to more webinars. You'll be getting information about those, and they will be going out soon, and they'll be scheduled, and we look forward to it, and thanks for joining. Thanks, and have a great day.